We are going to continue our notes on solving addition and subtraction equations, but we are going to add integers now to our examples. Let's just remind ourselves that our goal when we are solving any equation is to get the variable by itself. To do that, we are always going to use the opposite or inverse operation. So let's take a look at this first example. If I want you to solve x minus 4 equals -8. Now, I know the previous video didn't show you this, but I get in the habit whenever I'm solving an equation to draw a line through the equal sign because I want to make sure that anytime you do something on the left, you are balancing it and doing it on the right. And I want to make sure that you're keeping things on both sides of the equal sign. So I know that my goal is to get that variable by itself, to isolate that variable. So that means when I look at what's attached to the variable here, it's a -4 or a -4. So if we're talking about using the inverse operation, the opposite of -4 or the inverse of -4 is +4 or +4. The reason we do that is because a -4 and a +4 cancel out and equal 0. We just don't write that 0 because it doesn't change the value of x. So if I add 4 to the left side of the equals, the left side of the line, I need to add 4 to the right side of the line. So when I look at the left side of my equation, I have just x left, and it equals whatever this side equals. Now, I really like to look at these expressions as separate numbers. We talked about this when we learned like terms. So I kind of look at everything like an addition problem. So I have a -8 and a +4. -8 and +4 are different signs, so you subtract, and I have more negatives than positives. So x equals -4. You could have also just solved the problem off to the side. You could have written -8 plus 4 and looked at that as separate signs and gotten the same answer. I will just continually use these circles to show that they're separate terms and you can combine them that way. We can always check that our answer is correct. I have -4 minus 4 equals -8. Again, we can do this two ways. I can say, well, I have a -4 and a -4. Adding numbers with the same sign, you add and keep the same sign. A -4 and a -4 then will be -8. Or you could change the problem, -4 plus -4, and that does equal -8. It will make your life a little bit easier if you start to look at those numbers as separate terms. Then you're really only using the rules for addition all the time. Okay, let's look at another one. Let's say, for example, you have -5 plus x equals -6. Again, I am going to draw the line down the center of my equal sign to show both sides of the equation. So our goal again is to get the variable by itself. My variable is +x. Remember, whatever is in front of your number is always the sign. If it's a plus, it means it's a positive number. If it's a minus, that means it's a negative number. So what I have to move then is this -5. I have to take that -5 and get it away from that positive x. So I'm going to use the inverse operation. Well, the opposite or inverse of -5 is +5. You have to think about the fact that those are always going to cancel out on that side. If I have -5 and +5, that cancels out to 0. So I know that that's correct. If it doesn't cancel out to 0, in addition and subtraction equations, then you haven't added or subtracted the right number. So I am left with x on this side of the equation. And then when I add 5 to the left side, I'm going to go to the other side. I'm going to add 5 over there as well. So let's look at what I have here. I have a -6 and I have a +5. I'm adding numbers with different signs, so I subtract, it's a 1. And I have more negatives than positives. So it's x equals -1. You could have also written that -6 plus 5 and solved it from there that way if you choose. Checking my answer, I'm going to plug in -5 plus -1 equals -6. And I'm adding numbers with the same sign. So -5 plus -1 does equal -6, and I know that my answer is correct. So then, what do we do when there are double signs? What do I mean by double signs? Let's say you're given a problem like this. X plus -10 equals -15. All right, so this right here is what I mean by double signs. You're given something that's plus a negative. Now, a lot of people start to get confused when they see stuff like that. We need to become familiar with what a double sign means. We have to remember in this case that if you have plus a negative, that means that you have changed a minus to addition and taken the opposite. So what you're going to do is you are going to rewrite this problem so it doesn't have a double sign. So instead of having x plus -10, it's going to be x minus 10 equals -15. We know we can do that because we know minus is plus a negative, and that's what it was changed to. Now we're dealing with a basic one-step equation. It's x minus 10. To get rid of that minus 10 or -10, I do the opposite, plus 10. I show that on both sides. I know that my -10 and +10 cancel out. I end up with x equals -15 and +10, which is -5. I can check my answer. -5 minus 10 needs to equal -15. I have a -5 and a -10, and that does equal -15. So we want to rewrite the problem so it has one sign. It's not required. If you want to just watch this part, you can. So if I have x plus -10 equals -15, you can continue to do the opposite like we did in the other ones. So the thing is, you have to remember you're only doing the opposite of the operation. You are not doing the opposite of the number. So what I would have to do here is I would have to minus, but -10 stays -10, and minus -10 on this side. So then I would be left with x equals, but now we can't just look at these numbers because we do have a double sign. You have to think about the problem. -15 minus -10. We have to change that to addition and take the opposite. So you do end up with -5 again, but you're dealing with a whole bunch of extra negatives that you wouldn't deal with if you just changed that double sign to a single sign and moved from there. Okay, so let's do another one like that. Let's say, for example, I have w minus -8 equals 21. Okay, so you should notice that this has a double sign. It's got minus a negative. So we want to rewrite that so it's only one sign. W minus negative 8 is going to become W, and minus a negative is plus a positive. So W plus 8 equals 21. A much easier problem to solve because we have less negatives to deal with. So W plus 8 equals 21. The opposite of positive 8 or plus 8 is negative 8 or minus 8. Those do cancel out, they're opposites. And minus 8 on the other side. I have W equals. Now, even in this situation, I look at it as positive 21 and negative 8. And I know positive 21 and negative 8 equal positive 13. But in reality, you could have just said, well, 21 minus 8 is 13 because it's two positives. Well, it's two normal numbers, bigger minus smaller, and you could just do the subtraction like we did at the start. Okay, so what I want to do now is quickly go through 4 examples with integers that also have fractions and decimals in them, just to get a little more practice with fractions and decimals and a little more practice with integers in our problems. Okay, so let's start a separate section in the notes. We'll get through these 4 quickly, and then you will be ready to work on your worksheet. Okay, so let's start with this first example. Negative 12 and 6/10 equals W plus 15. Now again, it doesn't matter that the variable is on the right side. I'm still going to put my line down the center so I know what I'm working with. Okay, so the W is what I want to get by itself. I have a positive 15 or a plus 15 attached to that. So I'm going to minus 15, and I'm going to go to the other side. I'm going to minus 15. Now I want you to know I strategically lined up that 15 in the problem to make sure that my decimals lined up. Now remember, when you're adding and subtracting decimals, you have to line up the decimals. I'm looking at these 2 problems, and I know that they are both negative, negative 12.6 and negative 15. So I could, because they're the same sign, I know I'm going to add and keep the same sign, I could do that addition right here in the problem. So I have negative 15. I'm going to add that 0.0, and I know I can add these 2 together. Now, it's funny, it looks like I should be subtracting, but remember, I have a negative and a negative, and when the signs are the same, you add and keep the same sign. So I know that 6 plus 0 is 6. My decimal's here. 2 plus 5 is 7, and 1 plus 1 is 2. And when I add numbers with the same sign, I add and keep the same sign. And that will equal W. Now, when I plug that back in, okay, I have negative 12.6 equals negative 27.6 plus 15. And now I see that I have different signs, a negative and a positive, so those would subtract. So 27 minus 15 is 12, so I see that it is negative 12.6. Really checking your work and making sure that you're following the steps and showing what's happening in the problem. Let's do another one with decimals. Let's say I have M plus negative 6.2 equals negative 1.83. Okay, so I'm hoping at this point you notice right away that you have a double sign in this problem. So what I want to do is I want to rewrite the problem so that I have a single sign and I'm not worried about all of those positives and negatives. So I have m. I know that plus a negative is the same as minus 6.2 equals negative 1 and 83/100. All right, so I'm going to draw my line in, make sure I see my halfway point. I see that to get m by itself, I need to move minus or negative 6.2. So I'm going to add 6 2/10 to this side, and I'm going to add 6 2/10 to this side. Notice again, I lined up my decimals. The thing is, when I line up my decimals in this one, I have a negative 1 and 83/100, and I have a positive 6 2/10. Because my signs are different, I need to subtract. And because I need to subtract, I do need to put the bigger number on the top. So I can't solve the problem right there as it is. I am going to have to show my work off to the side. 6.2 minus 1 and 83/100, just to make sure that I'm getting this right. I'm going to add that 0 there. You can solve the problem as I am. Hopefully I'm not making any mistakes today. So, as you can see, I get m equals 4 and 37/100. And now I have to remember to go back and decide if it's going to be positive or negative. Since my positive number has more, it's bigger, then I have more positives than negatives, so my answer will be positive. When you think about plugging that back into the equation, 4 and 37/1000 minus 6.2, you should notice you're taking a bigger number away from a smaller number, so it should turn out to be negative. So it works out nicely. All right, we're going to do 2 fraction problems, and then we are done. So let's try this one. Feel free to pause the video and do it on your own before we solve it together. Okay, so I have negative 3/5 plus k equals negative 4/7. People have preferences here. I understand that we know we're going to be adding and subtracting fractions. Some people like to rewrite the entire equation right away, having common denominators. You could do that, that's no problem. I'm more of the type of person that likes to find the common denominators when I actually need to. So I'm going to leave the problem as is until I get to that point. Okay, my goal, again, is to get k by itself. I have a positive k there. So I need to get rid of that negative 3/5 that's on the side of the equation. So the opposite of negative 3/5 is positive or plus 3/5. So I'm going to write that there. And I know that those two cancel out and become 0. And then I'm going to add 3/5 on the other side of the equation. Now, fraction problems to me take up a lot more space. Now I'm at negative 4/7 and positive 3/5. So I am going to solve this on the bottom of my notes here, finding a common denominator and showing all of my work. So remember, when you have negative 4/7, I am now going to write the negative with the 4 over the 7. I have to add 3/5. I'm going to find a common denominator. In this case, it just happens to be the 2 denominators multiplied together. I'm going to multiply negative 4/7 by 5 over 5, which gives me negative 20. And I'm going to multiply 3/5 by 7 over 7, which gives me 21. Now, I know that when I'm combining these, I only have to deal with my numerators. It's negative 20 plus 21, so that equals 1 over 35. You need to be willing to show your work in these problems. We can't always assume that we know what the answer is. We have to make sure we're taking the time to make sure we're doing these properly. So I'm left with k equals 1/35. All right, so let's do one more. Again, feel free to try it out. If I am looking at n minus negative 2/3 equals 1/8. All right, we should notice this is a double sign, so we want to rewrite this problem. Minus a negative is the same as plus a positive. So I'm going to write n plus 2/3 equals 1/8. Now I only have one sign. I know I can work through my problem. I have a positive n. I need to move the positive 2/3 or plus 2/3. So I'm going to minus 2/3 on the left because those cancel out and equal 0, and minus 2/3 on the right. So I have 1/8 minus 2/3. Let's figure that out. 1/8 minus 2/3. Again, my common denominator is just the two numbers multiplied together. I am going to multiply the 8 by 3/3, and I'm going to multiply the thirds by 8/8. 8 times 3 is 24, 1 times 3 is 3, 3 times 8 is 24, 2 times 8 is 16. You need to, at this point, notice that you are doing 3 minus 16. You can do this two ways. We know 24 stays our denominator. You can do one of two things. You can either change it to addition, take the opposite, and say, well, I have 3 plus negative 16, adding numbers with different signs. I know the answer is, so you subtract 13, and it's negative because you had more negatives than positives. The other thing you could have done is you can look at the problem and say I have a positive 3 and a negative 16, like we've done all of the other ones, and that also, again, gives you negative 13. So when I look at my final answer, I get n equals negative 13/24. All right, I need to make sure you show your work on this worksheet and take your time so we're not making silly mistakes. Good luck.